So let us discuss about the graph theory. So let us define a graph. A graph is an order pair of vertex set and edge set, right? Look at this example here. Look at the vertices v1, v2, v3, v4 and v5. So these are the vertices, and look at the edges e1, e2, e3, e4, e5 and e6. These are the edges. So the number of vertices is known as the order of this graph. So here I have 5 vertices, therefore the order of the graph is 5. The number of edges, that is the size of the graph. So in this graph I can say 6 edges, therefore I can say that it is size of the graph. So let us look at the edge e6. The starting point of e6 is v3 and the ending point of e6 is also v3. So this is known as a loop. And look at the edges e4 and e5. So the starting and ending point are the same. So I can say that these two edges are multiple edges. And let us define adjacent vertices and adjacent edges. So look at v1 and v5. So between v1 and v5 we can see an edge e1. So I can say that v1 v5 are adjacent vertices. And if I want to define adjacent edges, right? So take any two distinct edges. Those two edges are said to be adjacent edges if their end points are the same. Look at e2 and e6. The end point of e2 is v3 and the end point of e6 is also v3. So these two edges are adjacent edges. So let us define totally disconnected graph as well as trivial graph. So totally disconnected graph means it is a graph with no edges. So that is known as totally disconnected graph. Trivial graph means it is a graph with one vertex and no edges. So that is the trivial graph. So look at the difference between the trivial and totally disconnected graph. So in the trivial graph, the number of vertices should be 1. But in the totally disconnected graph, there is no restriction on the number of vertices. Okay. So simple graph. So as we all know that a simple graph means it is a graph with no loops and no multiple edges, right? So if I have a simple graph with n vertices, then that graph has at most n into n minus 1 by 2 number of edges. Okay. So let me define a complete graph now. So let me consider a simple graph G. So then that simple graph G is said to be complete if every pair of distinct vertices of G are adjacent in G. Okay. So a complete graph with n vertices is known as Kn. So look at K1, right? Look at K2, I have 2 vertices, between them I can see an edge there. So look at K3, I have 3 vertices and between any 2 distinct vertices I can see an edge there. Look at K4 and K5 and observe the number of edges. Okay, so we can see that. So in a simple graph, up to maximum it has n into n minus 1 by 2 number of edges. In case of complete graph, it has exactly n into n minus 1 by 2 number of